Hello guys, in today's video we are going to see some more compounds of nitrogen. In the previous videos we have seen about group 15 elements and their general physical and chemical properties. Then we have seen about the preparation, properties and uses of dinitrogen. So in today's video we are going to see some more compounds of nitrogen, which means their preparation, properties and uses. So we're going to start with ammonia. Ammonia is NH3. So we will start with the preparation of ammonia. So before that, ammonia is one of the most useful compounds of nitrogen. It is present in air or soil, and it is formed by the decay of nitrogenous organic matter, which is urea. So you can take that as a preparation of ammonia. So urea is NH2CONH2. When it is treated with water 2H2O, you're getting ammonium carbonate, NH4 twice CO3. And this decomposes to give you 2NH3 plus H2O plus CO2. So this is how ammonia is formed in air or soil by decay of urea. Next one is small scale preparation of ammonia. For small scale preparation, which means for laboratory preparation, you can heat ammonium salts with caustic soda or lime. When we say salts, you know about neutralization reaction. When an acid reacts with a base, you will get a salt. So if you want to take an ammonium salt, you can treat HCl with ammonium hydroxide. HCl is an acid, ammonium hydroxide is a base. When they react, you will get a salt, NH4Cl. So when you take this ammonium salt and treat it with lime or caustic soda, see CaOH twice is Slaker lime, calcium hydroxide, you are getting ammonia 2NH3 plus 2H2O plus CaCl2. It is very important that you write the balanced equation. And regarding inorganic reactions, it is very easy to write the reactions because once you know what is reacting, you can easily predict the products. Whatever you have here, you're going to get the same species in the products also. So you know you're preparing ammonia and you know the formula for ammonia, NH3, and you know you're taking ammonium salt. What is ammonium salt? NH4Cl. Caustic soda or lime, you're taking calcium hydroxide. This is how you have to learn a reaction and write them. So when you take ammonium chloride and treat it with calcium hydroxide, see NH3. Along with that, you're getting water, H2O. You have calcium, you have chlorine, so calcium chloride, CaCl2. Instead of ammonium chloride, you can take ammonium sulfate also. Ammonium sulfate is NH4 twice SO4. When you treat sulfuric acid with ammonium hydroxide, what is the formula for sulfuric acid? H2SO4. Ammonium hydroxide is NH4OH. So instead of H2SO4, instead of that H, you are getting NH4. So that's the reason you're putting NH4 twice. So this is how you have to analyze and learn one reaction. So simply if you just mug it up and write, then you tend to forget those reactions. So try to correlate it with whatever you know, already known information, and then try to frame this equation. So you're taking ammonium chloride here you're taking ammonium sulfate. Here you treated HCl with NH4OH, HCl, just one H, so you got NH4Cl. Here H2SO4, so 2H, so NH4 twice SO4, and you're treating it with 2NaOH. You're getting same products, and 2NH3, 2H2O. Here you had calcium and chlorine, so you got calcium chloride. Here you are having sodium and SO4, 2 minus, so Na2SO4. So once you know the valencies, then it will be easy for you to write the compounds. You would have studied about these valencies in grade 9. See, Na plus, SO4 2 minus. So SO4 2 minus Na, you just cross multiply and you write Na2SO4. So that's how you have to write the products. So for small scale preparation of ammonia, you are heating ammonium salts with calcium hydroxide or sodium hydroxide. So you get NH3. For large scale preparation, which means for the manufacture of ammonia, you're going to do it by a process called Haber's process, which we have seen already. But here we are going to see it in more detail. So you're going to take nitrogen, treating it with hydrogen gas gives you ammonia. See, N2 gas plus 3H2 gas gives you 2NH3 gas. And this reaction is an exothermic reaction. Exothermic means heat is given out. So delta FH naught, which means formation of ammonia, H naught enthalpy change, is equal to minus 46.1 kilojoule mole inverse. If it is minus here, then heat is given out. So that represents an exothermic reaction. If it is plus here, then it is endothermic, which means heat is taken inside. About this reversible reaction, we have learned about this in grade 11 under the topic chemical equilibrium. So when we have a reversible reaction, you have certain favorable conditions. When you apply that, you can get more yield. Here yield is ammonia. If you want to get more yield, the reaction should be proceeded in forward direction. Actually, it is taking place in both the sides because equilibrium is reached. So both forward and backward reaction will be taking place at the same rate. But I want ammonia. So how to get more ammonia? That was studied by Le-Chatelier, and we have a principle called Le-Chatelier's principle. When a system at equilibrium is subjected to disturbance or stress, the equilibrium shifts direction either to forward or backward to nullify the disturbance or stress. So when you are disturbing this equilibrium, when we say disturbance, what type of disturbances you can give? You can either change the concentration of reactants or the products. Second thing, you can either increase the temperature or decrease the temperature. Third thing, you can either increase the pressure or decrease the pressure. So whatever disturbance you give, the equilibrium shift in one direction so that the disturbance is nullified. It is made nil. So now let's start with temperature. It is an exothermic reaction. We know low temperature will favor the formation of products if it is an exothermic reaction. And this is the exothermic reaction, forward reaction. And I told you already, I hope you remember, if the forward reaction is exothermic, then the reverse will be endothermic. I want forward reaction to happen because I want more ammonia. So if the forward reaction is exothermic, if you lower the temperature, then forward reaction will be favored. Or you can simply say, if you lower the temperature, more exothermic reaction will be favored. If you increase the temperature, more endothermic reaction will be favored. So we know this is an exothermic reaction. So lowering the temperature will favor the formation of ammonia. But at low temperature, the rate of the reaction will be very slow. So we are not going to use a very low temperature, but we are going to use an optimum temperature for the reaction that has been found to be around 700 Kelvin. So for the yield of ammonia, one favorable condition is optimum temperature of around 700 Kelvin should be used. Now coming to pressure. A pressure of 200 atm or 200 into 10 to the power 5 Pascal. This temperature is used so that the formation of ammonia is favored. Next one is use of catalyst. Here we are using iron oxide with small amounts of K2O and Al2O3. This mixture will favor the formation of ammonia. If you have any doubts in Le-Chatelier's principle and this how to decide on this high pressure or low pressure, then you can watch the grade 11 videos of chemical equilibrium, so you will have an idea. So what are the favorable conditions according to Le-Chatelier's principle for the manufacture of ammonia by Haber's process? High pressure, optimum temperature, which is actually a low temperature, but we are using an optimum temperature approximately around 700 Kelvin. And third one is use of catalyst. And this is the flow chart for the production of ammonia. See, you're sending hydrogen and nitrogen gas here, and this is the compressor where you give this pressure, and this hydrogen and ammonia gas, they will pass through this. Here we have the catalyst, iron oxide, Al2O3 and K2O, and when it passes through this pipe, what happens? The reaction takes place between hydrogen and nitrogen to give you ammonia. And this ammonia is in liquid state. This liquid ammonia, it is in gaseous state. This gaseous ammonia will be sent through a condensing area where it will be liquefied. So you have liquid ammonia here and it is collected. And if there is any unreacted hydrogen and nitrogen, that will be circulated back to the reaction area, to the reaction pipe, because only ammonia is liquefied here. And the remaining hydrogen and nitrogen will pass here, and it is mixed with the fresh incoming gaseous mixture of hydrogen and nitrogen. So this is the flow chart for the production of ammonia. So this manufacture of ammonia is done by Haber's process. Now we will move on to the properties of ammonia. So we will see the physical properties of ammonia. Ammonia is a colorless gas and it is pungent smelling. It will be kind of suffocating smell. And the freezing point of ammonia is 198.4 Kelvin and the boiling point is 239.7 Kelvin. And you can see the boiling point and it seems to be higher. So ammonia has higher melting and boiling points. It is due to hydrogen bonding, because nitrogen is bonded with hydrogen in ammonia, CnH3, and nitrogen is more electronegative, so it gets a partial negative charge and hydrogen gets a partial positive charge. So they will be having intermolecular hydrogen bonding, which happens between one molecule of ammonia and another molecule of ammonia. So due to the presence of hydrogen bonding, the boiling point of ammonia and the melting point is higher. And the next one, it is extremely soluble in water. Ammonia is extremely soluble in water. And ammonia has a trigonal bipyramidal structure. It actually has 3 bond pairs and 1 lone pair. So because of bond pair lone pair repulsion, which we have already seen in the previous video when we studied about hydrides. So this is the structure of ammonia. And I told you it has 3 bond pairs and 1 lone pair. So because of that, the bond angle is 107.8 degree. We actually expect the tetrahedral bond angle, which is 109.28 degree. But because of the lone pair bond pair repulsion, it reduces to 107.8 degree. So the HNH bond angle is this, and the NH bond length is 101.7 picometer. So these are the physical properties of ammonia. Now moving on to the chemical properties of ammonia. I told you ammonia is highly soluble in water. So when you dissolve ammonia in water, you will get an aqueous solution of ammonia. And that aqueous solution of ammonia is weakly basic. It is basic in nature. See, when you treat ammonia with water, it dissolves in water, NH3 gas plus H2O liquid, you will get ammonium hydroxide, NH4OH. And this dissociates to give you NH4 plus OH minus. So the weakly basic nature of ammonium hydroxide is due to the presence of OH minus ions. So how can you say a solution is basic or acidic? By using litmus paper. When we say ammonia is weakly basic in its aqueous form, then it will turn moist red litmus paper blue color. So that shows ammonia, aqueous solution of ammonia is basic. And next one, you know, just now I told you about neutralization reaction. It happens between an acid and a base. So when an acid reacts with a base, you will get a salt. Same way, since ammonia being weakly basic, so when you take ammonia and treat it with any acid, it actually neutralizes the acid, forming the corresponding salts, NH4Cl. NH3 plus HCl gives NH4Cl. And same way, when you take the aqueous solution of ammonia, which is nothing but NH4OH, that reacts with H2SO4 to give you NH4 twice SO4 plus 2H2O. This is what we have taken, this two, to prepare ammonia on small scale, laboratory preparation. We have taken this ammonium sulfate and ammonium chloride. So when ammonia reacts with HCl, you are getting back ammonium chloride. Same way, when ammonium hydroxide reacts with sulfuric acid, you are getting ammonium sulfate. When we studied in equilibrium, chemical equilibrium in grade 11, about acids and bases, we have different definitions. We have Bronsted acids and bases, Lewis acids and bases, Arrhenius theory of acids and bases. What is Lewis acid and base? When a species can donate electron, we call them as Lewis base. When a species accepts electron, then it is a Lewis acid. Here, ammonia has a lone pair of electrons here. on nitrogen. So it can give that electron. So that makes ammonia a Lewis base. Why ammonia is a Lewis base? Due to the presence of lone pair of electron on nitrogen. We have studied in coordination compounds. When a species can donate electron, it can form a coordinate bond with electron deficient molecules or any transition metal cation which are having vacant d orbitals so that they can form complexes. So when you take ammonia, see, you're treating it with copper sulfate. So you're getting Cu NH3 4 SO4. Copper is a metal. So ammonia donates the electron pair and forms a linkage with metal ions to form a complex compound. So this is a complex compound. See, this has a blue color and this complex has deep blue color. So this is the reaction. So if you look at your textbook, you will have this reaction in ionic form, which is nothing but see, CuSO4 is aqueous. So it dissociates to give you Cu2 plus and SO4 2 minus. This Cu2 plus reacts with NH3 to give you this complex. So Cu2 plus is blue in color, and when it forms this complex, now it is deep blue in color. Next reaction is with AgCl, silver chloride. Silver chloride is white precipitate, it is a solid. You're taking silver chloride and treat it with ammonia, 2NH3. You're getting AgNH3 twice Cl. Here it is white precipitate, now it has become colorless. Same way for the ionic form, when you take AgCl, it actually dissociates into Ag plus and Cl minus. So this Ag plus is coordinated here with ammonia because ammonia is going to donate electron pair. So now you get this complex compound. So these are the properties of ammonia. So we have seen physical and the chemical properties. Now we will see the uses of ammonia. Ammonia is used in the preparation of nitrogenous fertilizers such as urea, ammonium nitrate, ammonium sulfate, ammonium phosphate, calcium ammonium nitrate, which is abbreviated as CAN. All these are used as fertilizers and they are nitrogenous fertilizers, and ammonia is used in the preparation of these fertilizers. Liquid ammonia, it is used as a refrigerant in ice factories and cold storages where you want to preserve things. Liquid ammonia is used as a refrigerant. And ammonia is used in the manufacture of many inorganic nitrogen containing compounds. A very important such compound is nitric acid. Ammonia is used in the manufacture of nitric acid. So we have seen about ammonia, how to prepare ammonia and the physical and chemical properties of ammonia, and also the uses of ammonia. Regarding the questions asked on this topic will be reason out questions. They will ask you why questions, like why does ammonia act as a Lewis base? Why the boiling point of ammonia is higher? So questions like this will be asked, and they will ask you questions based on these reactions. They'll ask you how ammonia reacts with Ag plus or how it reacts with Cu2 plus. So then you have to write this equation. Very importantly, the reaction should be balanced. So most of the assertion reason type of questions will be asked from this part because you have a lot of reason out questions. So there are more possibility for asking assertion reason type of questions. So you should be very thorough with the reaction. So please practice the reactions and try to understand the reactions and then learn them. Thank you.